problems of technology were really coming to the fore. The rise of AI, the rise of sort of the attention economy on the internet, the robotic automation and all the problems and dangers that robots pose. So I thought, this time, I can't just be not caring about the technology or just being kind of a Luddite, which is my natural nature with these things. I really need to figure out what's going on here. It's all around me. I'm clearly a part of it. I want to understand this. So I did, of course, I have a degree in history with these things, and the first thing you think when you're a historian, I'm just going to start to read a lot of books. So I went out and I spent like a couple of summers just reading book after book after book after book, and there's a lot of bad history out there. There's even more bad futurography, or whatever you would call this sort of thing. Most of these were just terrible books. Didn't tell me anything that I wanted to know. I can't recommend them, but one of them was really good. No, more than one. There were several of them were good, but one of them in particular stood out, and it's this book called Trillions. I really recommend it, and it stood out because it talked, first of all, just that it was a very, very good book, and it actually made me feel like I understood something or why something was important or what its potential was in a way that I had not before, which was what I was looking for from these books, trying to understand technology and where it's going. And it was about the Internet of Things. And that was especially interesting to me because it was really interesting to the company I was working for then and now, which is a company, Autodesk, that makes software that people use to make things, or to design things and to make things. And the conversation at the time in the company was, well, why don't we make software for using things, right? There's this Internet of Things where you design the thing, you make it, you send it out to the world, but you continue your relationship with it. It's sending data back to you, you figure out how this thing is really working, maybe you make better ones in the future, and we should be involved in that. We should be making that software as well. What a huge opportunity that would be. So, great, my company's interested in this, I'm interested in this, and a really wonderful coincidence, the guy who wrote it, one of the authors, turns out to be at Autodesk. I think it was David who pointed out to me that this guy was there. So I was very excited about that, and I went to meet him, and I got to know him, and he invited me to join him in a project he was doing at Autodesk, which became this project called HackRod. And the idea with HackRod is that we would take a car, it's a very primitive car, you can see it's kind of nothing more than a frame, and we had a motorcycle that somebody had crashed, some Ducati or something, and we pulled the engine out of the motorcycle, and we stuck it in the car frame, and we put sensors all over the car and all over the driver. And we took it all out to the desert, and we ran it around the desert, and we collected billions of data points from this experience. And the idea was that we would then be able to use this to give feedback into how you design a car. All right, we've got all this data about how the car actually works, so now let's go do another revision of this car. It was an incredible story. It drew a huge amount of attention, and to this day still continues to get a lot of interest. But we didn't actually ever really do anything very impactful with the data that we got on. So it was, which happens a lot with these things, right? People go out to collect data, and then what are you actually going to do with this? It turns out to be really quite hard to make effective use of the data. So that's one of the fundamental challenges, one of the really big challenges with the
What
IoT.
do you do with it? Yeah.
And but it was a good project, and I was interested in trying to find another project of this sort. And at that point, my friend and coworker David introduced me to MX3D, and I was on sabbatical at the time. This is the summer of 2016. We were in Amsterdam traveling, and Felix and I came here to these offices and visited, and many of you may have just met Gijs, who's the CEO and the guy who kind of got all this started. He was here a little while ago, and we met with him, and we talked to him about this incredible bridge project that he was doing. And I suggested to him that given that what they were doing was so cutting edge, that these materials that you have, they're just completely unlike anything anybody's ever made, right? We know how an aluminum or steel rod, how that's going to perform. We know how it's going to perform under different environmental conditions, under different load. We know what happens when it fails. We know what it's going to look like when it starts. We don't know any of these things about these metal structures that MX3D is creating. Done material testing and starting to build up the knowledge, but if you're going to build a whole bridge out of this stuff, why not put sensors on it and get the data off the bridge as it's in use, as it changes its temperatures, people use it, so we can start to see how this material actually performs. And since bridges have a nasty habit of falling down, and that seems to happen a lot lately for some reason, let's also use that data to monitor if the bridge is starting to do something really out of bounds of how it's supposed to be working. And this was an idea that we talked about it for like 45 minutes, and at the end of it, he said, this sounds like a good idea, we should do it. And I went home and realized, of course, that I had no idea how to do this at all. I had tried to build an Internet of Things doorbell. I never managed to get it to work, so jump from doorbell to entire functioning bridge seemed like a big jump. So I did what I always do with these problems, which is that I went and I talked to David over there, and he's the guy who introduced me to MX3D, and he also happened to be working in a lab with robots that do the same trick that MX3D does, right next door at Autodesk, right next door to a machine room we have, which has a bridge in it. And he said, well, I don't know how to do it, you don't know how to do it, but we have a bridge, so let's figure out how to do it. Let's prototype.
Is it Pier 11?
Pier 9.
Pier 9?
Yeah.
Okay.
So we decided we'd do it, and this is him up on the ladder trying to get a device stuck to the side of the bridge there as part of this. And he also pointed out to me that because we had this conversation going about, hey, shouldn't we be getting into IoT? Well, we have a research division, and research's job is to be out in front of the rest of the company, developing software and ideas and technologies that might be of interest to the company in the future. So great, it turns out there's some research scientists and software developers in our research division who've been developing IoT software. So we already had software that let us visualize this bridge we wanted to make smart, that let us show where we had put sensors on it, all those little green dots, and which let us see it take the data off the bridge from those sensors that you just saw David putting on it, and then actually see what those sensors, the readings that were coming out, the data that was coming out of those things. So all the pieces were kind of there. And that was great. So we built that thing, and we taught it to do we had one goal for this. We taught it to do this one really good trick, which is to tell us how many people are on the bridge. And it learned to do other things, like it can tell if there's a dog or a person, and it has some other stuff. But the key thing was how many people are on the bridge. That's the one thing we want to be able to know. So we got the prototype to do that, and that was great. And that taught us what we needed to know to be able to go to Dutch Design Week just 2 weeks ago, I think, where we had the bridge up doing with these visualizations, showing how the data is giving feedback to us and what it looks like, and how the cameras see people and sees them in that interesting form. And that was really great. And at that point, I felt like I'd really accomplished something, and I felt like I really knew something about the Internet of Things, this thing that I'd set out to do. And everybody, of course, is very happy about that for me, and is really excited for me that I've achieved this thing. And it really feels like a great achievement. But you shouldn't all be too happy, because while I've been doing this project, other people have been out there working on the Internet of Things also have been building their own Internet of Things projects, and a bunch of those projects are evil. So this is a picture, a map of the spread of something called the Mirai botnet. So when people connect things to the internet, they don't usually take any trouble to connect them securely to the internet. And the result is that there are hundreds of thousands of devices that are connected to the internet that you can reach through the internet and which have no protection at all. So you can go across the internet and you can find this device, and you can use this device remotely without the people who put it there probably knowing anything about it. And one of the things you can do is you can assemble tens of thousands or hundreds of thousands of these devices into what's called a botnet. And then once you have lots and lots of these little computers embedded in all these devices, working all together to do whatever you want, you can do them to use them to do things like what's called a distributed denial of service attack, where they all try to contact one internet node at the same time and bring it down. And even such very technically sophisticated operations as Twitter, GitHub, were brought down by this botnet. So this thing spread, it's still active, it's still out there, and there's some criminal actor who has control of this thing because the Internet of Things has not been built properly. So that's a bummer. And that actor also has access to the data from these things, and most of those things are cameras. The other example that I really don't like of how the Internet of Things would develop is the surveillance state, right? So China has a program that they are investing in very, very heavily. It is a fantastic technical example of
amazing.
The Internet of Things.
Amazing.
Incredible. Yeah. They're going to have, by I think it's 2020, 500 million IP cameras installed in 55 cities in China. These cameras go back to absolutely cutting-edge AI technology, which monitors them and feeds into these horrible systems of a sort of combination of your credit score and your your favorite thing on Facebook and what all, and it's really amazing, and it's really super awful.
Oh, the NSA is pretty good too.
I'm not saying that China is the only place where this happens. It is by no means the only place where this sort of thing is happening. So the Chinese, though, call it sharp eyes, which I really think is like, But anyway, we have this same sort of thing going on in the States, of course, right? And everywhere else where you've seen these cameras springing up. And I really do not like this. I do not want to live in a world where people are spying on me all the time, no matter how cute and nice they may be. That's not the world I want to live in, and it's not the world I want all of you lovely people to have to live in either. So how is this project going to save us from that world? And my answer is that this project is intended, it has been intended from the beginning, not just to provide the engineering knowledge around how this new fantastic material works, but also to establish another method for the Internet of Things, for these things that are out there, these big things, these infrastructural things, to do what we need them to do. For example, know how many people are on them, without violating everybody's privacy in these horrible ways. Okay, so how are we going to do that? This is the place in the red light district where that's the bridge that's going to come out where the MX3D bridge is going to go in. Right? Wow. You can see it is very crowded, and it is in the red light district. And why did I have this picture here?
It's complicated.
Very crowded. That's my
complicated. Yeah.
And yes, and it's very crowded, and that's a really big problem for the city. And the city is, Amsterdam, as I think most of you know, right, is experiencing a lot of population growth. But the city itself, although it is growing, it's building a lot, it needs to deal with this population growth much more effectively than it is. And I think until you have the data, and the city obviously agrees, you can't really deal with that effectively. So the city is doing research so that they can deal with crowd management issues. And they're doing that research, among other places, right here where our bridge is going to go. So that box, that junction box there, is where that sign I just showed you sits. And that camera above it is, they're pulling data off of that camera to do counts of pedestrians who are going through that, to do their research. And as you can see, there are definitely people who like to just stop on the bridge. There are a lot of them, and they're there even in that last picture. Like, no matter how crowded the bridge gets, there always seems to be somebody who wants to just be standing on it. And that's fine. That's a really good use case for a bridge. Bridges are not there just to get you from one side to the other. But if you're a tourist and you come to the red light district, you come to see the red light district, and in fact, most of the time all you've seen is the back of the head of the other tourists who have come to see the red light district. You know, you get on a bridge, and it's a very natural thing to want to stop and look around because you actually have a chance to see the lights and the water and the two sides of the canal and everything that you actually come there to see. However, under certain circumstances, that's a terrible idea, right? Because these bridges, as you saw in the previous picture, they're terribly crowded, and you cannot have things get choked up at a point like that, right? Bad things can happen, panic, freezing of the traffic flow. So that is what we want to avoid, and that's why they're looking at it. But the other thing that I don't like about this picture is the camera, right? This is the red light district. There shouldn't be cameras in the red light district. The ladies who work in the red light district do not want cameras in the red light district. The gentlemen who visit those ladies definitely do not want cameras in the red light district. And all the idiots who go there to party probably aren't thinking about it because they're too drunk, but if they did, they would also say, we do not want cameras in the red light district. Cameras don't belong there. It's not a good environment for it. So this is a picture taken just a couple weeks ago of the bridge when it was down in Eindhoven at the Dutch Design Week. And we won there the Popular Jury Prize, which makes me think, okay, people like the bridge, which is very important because if you're going to stick a bridge in somebody's neighborhood, it's good to know whether they're going to like it or dislike it. So that's a really positive sign. But you'll see here, we have these big poles, right? And that was Casper's job, tripod, that's what that's about. We have these big poles, and on top of the poles, we do have cameras. So part of our project involves cameras. But there are also lots of other sensors on the bridge. So I didn't expect it to be quite so dark out there. But if you looked closely on the bridge and you were able to see in the dark, you would have seen little boxes all over and lots of wires running all over the bridge. So yes, there are two cameras watching the bridge, stereo vision, it helps you deal with issues of occlusion and such, but there are also lots and lots of other sensors on it. There are inclinometers and accelerometers and load, things that measure the weight of the thing, and strain gauges. So there are all these sensors on the bridge that measure its physical response, its changes in shape to things that happen in the environment. Changes in temperature and then changes in like who's on the bridge actually using it. We need temperature, we need thermometers, right, to measure changes in temperature, for example, to understand that environment. And we also need cameras to understand what's actually happening on the bridge, right? And this is one example of something that can happen on a bridge when we were doing our load testing. But we have a plan. And the plan is inspired by, should I give it away? A game that we used to play as children, where you would draw, one brother would draw a letter on the other brother's back, and the other brother would have to guess what that letter was. Now, I don't know if we're actually playing this, and I also don't know if that's your bare butter, if your pants were really tight, Chris, but that is the game that we're trying to teach the bridge. And so the idea is that those cameras are going to film all of this activity on the bridge, and they're going to generate lots and lots and lots of events, things that happened on the bridge. So we have these computer vision, these AI computer vision capabilities. That's what the cameras are there to, they're there to pick that up and to feed that into this machine learning algorithm. And that's why, by the way, you saw earlier on that, actually we can show here, yeah, why that thing is skeletonized, right? We don't actually show the person there. We never use the raw video footage. We only use these skeletons because what the skeleton is doing is what we want to teach the bridge. Bridge, you have to understand, somebody touched your banister here, somebody had a footfall here, somebody stepped off you altogether. We can get all of that from the skeleton. And what we do is we take that information that we observe about the skeleton and we correlate it with the signals that we see in the rest of the sensors. Right, so this is a machine learning approach. It's not easy to do, and we haven't yet done it successfully even on the prototype. So this is prospective, this is hopeful, but the idea is that we can teach the bridge to get good enough at this that at a certain point we'll be able to take the cameras away altogether. And then the bridge will be there, and it will still be able to tell you how many people are on me. It may be able to tell you things like, do I see people running on me, right? Do I see somebody transiting me very fast? If somebody's running in the red light district, I guarantee you the police need to check that out. Is there somebody who's been standing in the same place for an hour, okay? If that's happening in the radio, 15 minutes, 5 minutes, it's somebody smoking a cigarette, 15 minutes, it's somebody having a romantic moment, an hour, that's a drug dealer on the bridge in the red light district, right? And you don't need to see the person to know that that's what's happening, right? So the bridge should be able to tell us these things and address a lot of use cases, and I'm hoping even enough use cases that at some point we can go back to the police and we can say, hey, you know that camera you have there? You should remove it. You don't need it. So not only do I hope that the bridge will be able to get rid of its own cameras, but I hope when they go away, we'll be able to start to take away some of the other bridge cameras in the red light district. So we're going to find that. Now, there are situations where one cannot reasonably expect even the most advanced machine intelligence to be able to deal with it. So this is not a panacea for everything. But the other thing is that it's not enough for the bridge just to know what's happening on it, and it's not enough for the bridge to tell us what's happening. And this is a mistake that I think a lot of people make in their approach to IoT, and that's why the cameras are there. People think about it and they think, well, I've got to be able to see what's going on. And I've got to understand, the way we understand things, as all these eyes look at me, is through our eyes, right? That's why we all have these big energy-intensive brains, is to drive this visual intake of information. And we just naturally think, it's a human bias, that when we think of how are we going to understand something, the first thing we want to do is put eyes on it, which is ridiculous for most of the internet, but that's a different rant. So we need to do more than just give the bridge the ability to understand what's happening on it. We need to give it actuation capabilities. Which is to say, we need to make it possible for the bridge to respond to the things that are happening on it. And whether that is it vibrates, or it makes sounds, or it has lights, or something like that.
Shakes off.
I think just from this picture, I took this picture the other day at a distance from the Maghreb, and when I looked at it, I just immediately thought, oh, the bridge isn't working. The bridge is closed. I'm not going to try to go there to cross it, right? So, a bridge can communicate something with light. I don't think that was really what the problem that was true with Maghreb, but anyway, it can communicate, M is communicate something with light, or with sound, or with vibration, or, we'll figure out how it communicates. But if we can give the bridge the ability to give feedback to the people who are on it, So if you're the drug dealer, it starts to become unpleasant to stay on the bridge. Or if you're the person who decides that now is the moment to stop in the middle of the bridge when there are 100 people behind you trying to cross, the bridge should be able to recognize this and do something about it. And what it does about it, I don't know. I don't have to figure that out, because if the bridge has appropriate machine learning and data capabilities, it will figure it out. It will experiment over time and it will optimize to avoid these situations that we want to avoid. People hanging out on the bridge for excessive periods of time, people blocking the bridge when there's a lot of traffic. So hopefully the bridge will start to figure out how to be a smarter bridge.
But what can the bridge do then?
Well, that's the part that we have to figure out. Like, what are the exact powers that you give the bridge?
Electric shocks.
And we've had, so people have suggested electric shock, people have suggested superheating a part of it at a particular point. What are some other good ones? Vibrating one. We had this idea at one time where maybe what it would do is it would, so like my hang up with this, because I used to live near the bridge, like a block away, remember? Right? Very near where it was going to go in. And every time you're bringing home groceries, there's somebody on the bridge. You're riding with your bike with like a milk crate or a beer crate on front, and there's somebody standing in the bridge taking a selfie, and you've got to stop and get off your bike. And, bridge, could you maybe tell them to get out of my way and maybe illuminate a lane and make it clear to people that there should be. I don't know what the answer is. Yeah. And this is just, we're just at the point now where the bridge is able to collect data and tell us things. And I'm hoping we'll soon be at a point where the bridge is able to do it without cameras. But getting to that point where the bridge is starting to optimize things in an automated fashion, we've got another couple of years to do it. But that's what we need to get. So, in summary, the formula that I hope I've explained, we should be collecting data from the things. We also do need to collect some video data in many cases for us, and so that we can help the thing learn. We need to use that data to train the thing to understand that sensor data, and we do that via machine learning. We need to use the output of those machine learning algorithms to drive these experiences, to give us the ability to react and drive those experiences. That will allow us to, and this is important, continuous dynamic problems, right? So the overcrowding problem in Amsterdam is not just one problem, it is not a static problem, it keeps changing, right? So to simply have a rule in place that says when you see this, do that, ain't gonna work, or at least it's not gonna work for very long. So we need to find a way to bring the machine learning capabilities to bear in the physical environment so that these problems can be addressed in a continuously evolving way, because the problems themselves are continuously changing. And then finally, we need to do it so that it's not bugging me personally. And hopefully, we'll get it done before I turn 50. Of the bridge. These 5 massive servers. This is what it takes at this time to run the bridge, and we could probably get it to show you the data that's actually coming off the bridge right now. So these 5 very chunky servers were at Dutch Design Week capturing all this data and doing all this processing. And what they do is the video footage of everybody who walked over that bridge at Dutch Design Week is on one of these hard disks. It is here. Yes. But it never leaves this hard disk. What we're doing now is we're taking all this data off of these servers, but for the video data, we only take off the skeleton actions. Okay. So we never see that, we'll never leave these machines, it will never be shared with anybody, it will never leave the Netherlands or this room, the actual video data. But the skeleton did here, and stepped here, and touched here, and got off the bridge there, that all goes.
And you don't collect any data from the mobile phones?
We do not collect any data from the mobile phones. But the people who are doing the counts in the red light district right now in the temporary bridge are.
Oh, really?
Yeah. So when the city sets out to do this, they say, oh, that's a good way to collect data, and we're going to do it. Now they take steps to anonymize that data and be responsible with it, and that's all okay. But it seems to me a better way is not to be asking questions of things that are in people's pockets, and not to be taking pictures of them, and not to be recording their conversations. So let's try and do it without all that stuff.
Yeah. What do they collect now then from the mobile phone? All the
your Wi-Fi requester, I think it is. Yeah, I'm pretty sure it's the Wi-Fi.
Bluetooth.
it's either Wi-Fi or Bluetooth, but I think it's the Wi-Fi. So if you're walking around with your phone on with the Wi-Fi on, it's just periodically saying, "Hey y'all, who's here? I'm so and so."
With your name also.
Not your name, but with an identifier that is unique to your phone.
iPhone of Olga.
Olga's iPhone.
Olga's iPhone.
Yeah.
And indeed, if you're going to give me the name of your machine, yeah, I'll use that. I'll use whatever you give me.
Oh.
You know, if you don't like this,
I wasn't giving anything.
well,
Taking it.
you're broadcasting, right? So I keep my phone I only use mobile data. I don't even use wireless at home.
Also the cat which
Yeah.
crossed the bridge and its chips.
I want the bridge to be able to tell when it's me with my beer crate and not some tourist.
So
Why don't we do a thing where we put an RFID chip in the keychain of every rental bike in Amsterdam? Everybody walking around with that chip in their pocket's a tourist.
Or you can also see the...
So one of the really funny
What was the
things-
question?
The question was, can the bridge tell if somebody's jumping on it? And I know the bridge can tell if somebody's jumping on it because we, in that pier prototype, that bridge that we built back in Pier 9, that bridge is in a workshop, a very sort of futuristic space that we like to show off to customers. And so tour groups come through very regularly. And as soon as we told the people who ran those tour groups that the bridge was collecting data, they started jumping on it. They couldn't see it, there wasn't any feedback, the sensors weren't really obvious, but as soon as they knew that the bridge could collect data, every time they came with a group of people, they would jump. And we would see these like 10-person tour group events, and we would see these 20-person tour group events. And so, yes, people jump on the bridge, and the bridge sees it, and we see it.
Between dancing and jumping.
Sure. So I believe, we haven't proven this yet, but one of the things I want to do with the San Francisco bridge, but very much not with the Amsterdam bridge, is to put enough sensors on it with enough density of how they're spread that we can start to really understand individual footfalls and the patterns of those and what those look like.
Yeah.
And we know that your gait is highly distinctive. If we take a camera and film you from the side and watch the ratio of movement between your knee and your hip and all that stuff, I've heard that it is more distinctive than your fingerprints. Maybe we can get the same thing off your footfalls. I just brought it back from its first run out at the Dutch Design Week. And one of the really interesting things that we discovered at Dutch Design Week was, you don't see it here, but the bridge as it was at Dutch Design Week, and as it will be when it's installed in the red light district, has these big swirls at each corner. And it turns out that when people walk on the bridge and put vibration into the bridge, that vibration goes out to the corners and into the swirls. And the swirls hang out with that vibration, and at some point they pump it back into the bridge. So we're seeing these really unpredicted effects of that, and how that really affects the bridge mechanically is something that we can now understand and study because we have that data. So the sensors, otherwise we would have seen those things jumping up and down, and we would have thought, ooh, that's a problem, but we wouldn't have really known what to do about it. Yeah. Autodesk actually is not terribly interested in what I'm doing here with this idea. We want to make smart cities, and we know smart infrastructure is part of that, but the reason that Autodesk was getting into this in the first place was because of that, more along the lines of what that HackRod project was trying to do. The HackRod project is saying, let's design something, let's put sensors on it, let's use it, and then let's use the feedback from those sensors so that the next time we design that thing and make it, we do it better. Let's design the frame so that it now looks like this. And we have this concept of generative design, where the design itself is fed by this data and allows you to optimize within certain parameters. That's what Autodesk most cares about in the IoT. For Autodesk, that's really the primary use of the thing. I'm trying to demonstrate how this technology would work at city scale. And if we can do that, get beyond just the bridge, but if I can create a new project which goes beyond that and does something at the city scale, then the smart city thing starts to become really interesting. But that's yet another. That bridge is going to sit over water in the red light district. Those cannot be on the bridge. You may remember my boat and how much trouble I went to create these impregnable steel lockers on the boat that nobody would be able to get into, and how it just never worked. I don't want to have to do that, try and go that fool's errand with these things. So we need a place somewhere near where the bridge is going in the red light district where these things can have a home. So if anybody has contacts in the red light district, people who live there or businesses who are going to be near where that's going, I need to meet those people. because we've got to find a place for these things to live.
Why do
For
they
like
be near the
2 meters.
bridge?
Bravo!